Orbits are promises. A planet circles a star. A moon follows a planet. Everything returns exactly where it should. Until one orbit doesn't. This is the record of an orbit that moved without breaking. An orbit is a delicate balance. Gravity pulls inward, while the object's own motion pushes it outward. It's a cosmic tug-of-war. If you change either force, the orbit fails. The object either crashes into its star or flings off into the lonely dark of space. There is no third option, at least, there wasn't supposed to be. The anomaly first appeared during a completely routine orbital survey. A tiny blip on a screen, but it made no sense. A planet was where it shouldn't be. Not drifting away, not spiraling inward to its doom. It was still orbiting, perfectly, but it was orbiting. Nothing. Follow-up scans confirmed the impossible. There was no star, no black hole, no detectable mass of any kind at its center. Yet the planet continued on a perfect, stable elliptical path. It was an orbit without a center, a dance without a partner. Every sensor we had agreed, optical, gravitational, spectral analysis, they all told the same story. This wasn't a glitch in the data or a sensor malfunction. The orbit was stable, it was precise, and it was completely, utterly impossible. According to Newton's laws of universal gravitation, this cannot happen. According to Einstein's theory of general relativity, the very fabric of spacetime should collapse where the star used to be. But according to our direct observation, it didn't. The equations that have governed our understanding of the cosmos for centuries failed. Reality, however, did not. When we dug into the historical data, we found something even more disturbing. There had been a star there, but it vanished months earlier, one of the countless disappearances we've been tracking. And yet, the orbit remained. It was as if gravity itself remembered something that was no longer there. This is what we call the memory problem. Gravity is not supposed to have a memory. It's a direct consequence of mass. When the mass disappears, its gravitational influence should vanish instantly, at the speed of light. But here, the pull remained, like an echo of a shout that has long since faded, or a placeholder marking a spot that is now empty. The Vanishing Star Map, our master program designed to make sense of all this, couldn't reconcile the data. It tried. It erased the star from its records. It marked the planet as unstable, predicting its immediate departure into interstellar space. And then, it rewrote the orbit. The map itself adapted to the new, impossible reality. Then we saw it. The orbit began to slowly shift. It wasn't decaying or breaking apart. It was sliding. Moving through space as if it was recentering itself on something unseen, something not yet present. It was a ghost orbit, searching for a new anchor. This led to a radical theory, one that turns physics on its head. What if this orbit wasn't tied to the past, to the star that had vanished? What if it was tied to the future? What if it was locking onto a gravitational center that has not arrived yet? This is profoundly dangerous. If orbits can detach from their mass, if they can exist independently, then stars become optional. Centers become negotiable. The fundamental structure of the universe becomes temporary. The cosmos stops being a predictable, mechanical clockwork and becomes something else entirely. Adaptive, alive. We started looking for others, and we found them. More displaced orbits, always appearing after a star vanishes, and always near one of those shifted grid regions we've documented. The pattern is growing. Whatever is happening isn't just erasing things, it's reassigning them. Taking the motion that was there and giving it a new purpose. And where is it reassigning them to? All the displaced orbits we found lean subtly inward, toward the exact same point of convergence we identified in previous episodes. The universe isn't just throwing things away, it's gathering motion. It's redirecting the fundamental balance of everything, pointing it all toward a single, unknown destination. Maybe the universe isn't losing control after all. Maybe it's just letting go of old anchors. Stars vanish, grids shift, orbits relocate. The structure survives, but its loyalty does not. An orbit without a center should collapse. This one didn't, because the universe no longer requires what it once revolved around. The question is no longer about what has disappeared. The real question is, what is everything beginning to orbit instead? Thanks for watching. Follow for the next episode of the Vanishing Star Map.